Hello, fellow classmates. My name is Travis Jeter. Welcome to my video podcast on the properties of sound and audio reproduction. By now, I'm sure that we're all fairly familiar with terms like amplitude, wavelength, frequency, and hertz. What do these terms mean to us in relation to music? Well, for starters, each sound that we hear in music has its own unique frequency, which we describe in hertz. For example, a kick drum has a frequency of about 50 hertz, while a snare has a frequency of roughly around 100 hertz. Bear in mind, these are the frequencies of dry instruments, meaning no effects added and played in the most optimal environment. The amplitude of these waves is most understood as how loud these sounds are. Each sound played produces waves with unique wavelengths. For instance, a kick drum produces waves whose wavelengths are longer than a snare. Basically, the higher the pitch, the shorter the wavelength. The lower the pitch, the longer the wavelength. A few more familiar terms for us are constructive interference, destructive interference, reflection, and refraction. Believe it or not, constructive interference can work for us or against us in audio recording. Constructive interference occurs when two in-phase signals overlap, which increase the overall amplitude of the signal being played. This can hurt us if we have constructive interference in a sound like a hi-hat. This will make the sound louder than it needs to be and must be compensated for. Destructive interference is just that, destructive. This takes place when two out-of-phase signals overlap and cancel each other out, producing a flat sound, which we might hear as a really shallow low end in the overall sound. It is just as detrimental to the mid and high frequencies as well. Reflection is what happens when sound bounces from one surface to another, whatever these surfaces may be. Reflection hurts us in audio recording by becoming constructive or destructive interference. This will have to be compensated for, or what is heard when mixing will be a false representation of the overall sound. The sound travels through an object or is absorbed. This is what is termed refraction. Refraction in sound recording can work for you or against you. What takes place when refraction occurs is the material absorbs the sound, which changes the wavelength and thus changes the frequency of the sound. Now you may be asking yourself, how are all these things compensated for? Well, first, there are a few fundamental measures taken to alleviate the effects of them, regardless of the quality of the monitors or the acoustics of the room you're recording in. First in order of importance is the monitor placement. Monitors should be placed a minimum of 8 to 12 inches from any wall, preferably in the center of the room away from corners. The monitors should be placed so as to form an equilateral triangle with you, the listener, as the third point. Monitors most ideally should be placed on isolation pads and then mounted on stands so they don't produce resonance. The room should be free of any freestanding objects that will interfere with the produced sound. When done correctly, your recording environment should look similar to this example, with the tweeters at ear level of the listener. Next, you'll want to treat the room with some sort of acoustic material. This will help us to compensate for reflection and refraction. At minimum, all corners should be treated so that constructive interference does not give us a misrepresentation of the low-end bass. Reflection of the high frequencies will result in a muddy sound, where everything seems to just be crammed together. These few steps can make a world of difference in your recording. What they cannot compensate for are your ears. We need to develop good listening ears for the art, which takes time and experience. Thank you for taking the time to view my podcast. I hope it was as informative for you as it was for me.